Hello everyone, and thank you for joining me for this session. My name is Dave Rendon, and I'm a Microsoft MVP with expertise in Azure, and today we will review how you can improve network detection and response capabilities in Azure. And to simplify the deployment process, we will leverage infrastructure as code using Bicep. So let's get started, and we will review the following use case where typically organizations might be running on-premises web applications. And when the client tries to access this application, the request might go through a firewall or a load balancing solution that the organization might have in place. And in most cases, organizations don't have the right tools in place to visualize what's happening through the network. And this is where the Kemp Flowmon solution comes in place. And today we're going to deploy a network virtual appliance, which is called Kemp Flowmon in Azure, and we will use Bicep to deploy the solution. Kemp Flowmon is going to enable you to visualize what's happening through the network and detect anomalies and respond as needed. And as I mentioned earlier, we will use Bicep to deploy the solution. And probably you might be already familiar with ARM templates or Azure Resource Manager templates. These ARM templates can include the definition of the infrastructure and the configuration for your deployment. Now, the downside is that ARM templates are JSON-based, and while you can take a declarative approach, when working with more complex environments, it can be a bit of a pain to manage all of these ARM templates. Bicep then comes in handy as it provides you with an easier syntax, and it is important to note that ARM templates are not going away. Bicep is the new domain-specific language for deploying Azure resources and sits on top of the ARM templates. So when you create a new Bicep file and deploy it, it will transpile into JSON files and then talk to Azure Resource Manager to deploy your environment in Azure. This means that we will have all the benefits from the ARM templates, and we will be able to create the definition of the resources and configuration for our environment in Azure with a more simple syntax. To get started with Bicep, I recommend you to install the tooling available through this URL. I strongly recommend you to use Visual Studio Code and the Bicep extension. Also ensure that you are using the Azure CLI, at least version 2.20 and above, and Azure PowerShell. Now let's go into some of the prerequisites for this deployment. I will recommend you to create SSH keys for the VM instead of using a password. I will also recommend you to get a Flowmon license and also leverage Azure PowerShell. Now, previously I installed the Bicep extension and all the tools needed for this demonstration. So when you have in place in Visual Studio Code plus Bicep, we're going to create a new file called main.bicep. The first step is to create the parameters for our solution. In this case, we're going to deploy basically a Linux-based virtual machine, and then we're going to configure this VM. Now, as you can see, one of the benefits of Bicep is the simplification of the syntax in here. And to show you the difference between the ARM template, I'm going to open the ARM template that creates the same amount of resources for the solution. So on the left, you can see the Bicep file, and on the right-hand side, you can check the ARM template. Similar to ARM templates, in Bicep, we're going to create the parameters, variables, and resources as needed. Now we're going to proceed to validate our Bicep file. Again, we're going to provide the parameters for the virtual machine, such as the VM name, the admin username, the authentication type, which I would recommend you to use SSH keys for this use case, and then provide the actual value of the SSH key. Now for this sensitive data, I will recommend you to use the secure decorator to securely pass the SSH keys or the password for your VM, and the value is not going to be stored in the deployment history. Also, we're going to use a parameter for the DNS label prefix, and Similar to ARM templates, you can see that we are going to be able to use some functions in here, like to lower and the function to get the location from the resource group. Then we're going to leverage a few variables in here. And then we're going to start authoring the resources for our VM. In this specific use case, we defined a network interface and also the network security group. Within the network security group, we're going to provide some specific security rules to access to this VM. So we're going to provide a specific rule for the SSH, HTTPS, and also we have some custom rules for the Flomo collector. Then we define the VNet and the public IP. And last but not least, we're going to provide the configuration for the VM. Just as a note in here, it is important that if this is the first time that you deploy this VM, you probably need to accept the terms and conditions from this publisher. The next step is to pass on the parameters file. And we can do this during deployment time, or we can create a parameters file like this one and provide the required parameters for this VM. So I'm just passing a few parameters in here, such as the VM name, OS disk, the data disk, the network interfaces, and the SSH key. Now we're going to create the SSH key from the Azure portal. So let's go to the Azure portal and let's open Cloud Shell. And then we're going to create a new SSH key. And then we're going to provide this value in the parameters file. So I'm going to go back to the parameters file and we're going to provide this value in here. The next step then is to deploy this bicep file. And I'm going to use a console just for the sake of these demonstrations. What we will do is to deploy this bicep file. Before we do that, first of all, I'm going to log into this Azure subscription. So this script is going to just help us to authenticate to this Azure subscription. And before we deploy this bicep file, we're going to create just a variable to name our deployment. And now we're going to deploy this bicep file. For this, I have a quick script that deploys a bicep file and it's going to pass also the parameters file. And then we're going to provide the username Flowmon. This is a must for this specific NBA. Similar to ARM templates, we can use the what if command to validate our template. So in this case, we're going to be able to have a preview of the deployment of. So in this case, we're going to be able to have a quick preview of the resources that we're going to deploy before performing the actual deployment of these resources. Now we're going to proceed to deploy this bicep file. After a few minutes, you should see the deployment output. Now the next step is to access to this VM. In the resource group, you can validate the deployments. You can check all the resources deployed and also the deployment history. So we can check all the details in here. In case there was an issue, you're going to be able to track any potential problem in here. Now we're going to go and grab the public IP from this VM. Then the next step is to SSH into this VM. So we're going to SSH to this VM using the username Flowmon and the public IP of this virtual machine. Then provide the passphrase. And then we're going to execute the sysconfig command. Select OK. And now we're going to go to the password settings and then enter the password for the user account. Once this process is complete, now let's go to the now we will go to a new tab in here and access through HTTPS. We're going to access using the admin username and the new password, and then accept the license agreement. Once you accept the license agreement, then we're going to apply the new licensing here. So let's go to this license option, and then we're going to upload the license. So I'm going to choose the file. I'm going to come to desktop and then upload the license. Then you should be able to see a license similar to this one. We're going to use the Flowmon anomaly detection system to detect any anomalies in the network. Now, for the sake of this demonstration, I'm running a load master on premises, and I have the option to send network telemetry to a Flowmon collector. So I'm going to get the public IP from our VM. So I'm going to validate. So I'm going to set this remote address, and I'm going to export IPFix. Then in the Flowmon collector, we're going to be able to go to the anomaly detection system, and we're going to start looking at all the traffic going through the network. So in here, I can perform an analysis, and I can check on the events by priority. So I can check if there's any anomaly from SMTP, or if there's any HTTP dictionary attack, and I can then drill down on the events. This completes the session for today, and I want to recommend you some resources. You can find the template that we deployed in this GitHub repository and additional resources for you to learn about Bicep. And again, thank you. I'm very grateful to be part of this great initiative. And again, kudos to Gregor and the whole team behind this initiative.